All right, guys. So I have not known John Marlow for a long time. I think I only met him a few weeks ago here at Web3 Wednesday. But I will say something about him. I spoke to him for a few minutes, and I thought, we need to get this guy speaking here. He is extremely bright. I don't know what he's going to be talking about. I assume it's going to have something to do with Tezos. We have a nickname for him. It's Tezos God. But no, honestly, this guy is extremely bright, extremely knowledgeable. We're so lucky to have him, and I think everyone here is going to learn something. I mean, I actually, believe it or not, I had heard people talk about Tezos in a way that wasn't necessarily the most positive. And then I met John, and that night I went home and I invested in Tezos. That is how convincing and how eloquent he was. So everybody, please give him a warm welcome. John, thanks so much for joining us.
Sorry, guys. Hey, I just wanted to thank everyone out for coming. I'm going to be telling a little bit about my story and what got me into decentralized science. And joining me tonight, I have my friend Rook. And he's actually part of the DAO that we're starting on Tezos. That'll be my one Tezos mention. And it's going to be for decentralized medical research. So this is essentially why I think this is necessary. And I'm going to start with my personal story. So I have something called Ehlers-Danlos syndrome, and it's an extremely painful condition and exceptionally hard to diagnose. And I'm going to show you just how hard it was to diagnose. But some say it's worse than cancer pain. And if you go into support groups for Ehlers-Danlos syndrome, and you listen to them, usually it's just nonstop crying, talking about wanting to die, doctors not believing that they are sick, saying that it's a psychosomatic disorder. That means it's in your head. And Ehlers-Danlos just represents one of many rare diseases. That's one shout out to all the rest of them. It represents one of the many 11,000 rare diseases are known, right? And 10% of the global population has a rare genetic disease. So statistically, someone here might have one. They manifest at different, ages of life, but ultimately they ruin lives. And only 5% of them have treatments, actually even less than that. So 10% of the population just has to live in pain all the time. So anyway, yeah, it's a very painful condition. If you go to the next slide. So this was me, on my journey. I was, again, with a lot of these rare genetic illnesses, they're hard to diagnose. So, I was at hospitals just being chopped open, getting endoscopies in my intestines. Not endoscopies, full thickness biopsies of my intestines, endoscopies, experiment after experiment. And, after 17 years in the clinical space, going to Columbia, Johns Hopkins, the best hospitals, they could not figure out why I was sick. So, you go to the next slide. It's actually, yeah, so pause this for a second and turn up the volume. Can you restart that? Okay, so just
otherwise. It isn't a specific stomach ailment. It doesn't have a name or anything. I mean, it had been building up for so many years that I was, suicidal. I mean, I just didn't want to live. So I just thought, if I'm gonna die, if I'm gonna kill myself, I should take some drugs, May as well become a junkie, because I felt like a junkie every day.
To otherwise.
It isn't a...
So, some think that Kurt Cobain had Ehlers-Danlos syndrome because he had dislocations, he had constant gastrointestinal pain, and just like me, unfortunately he lived in an earlier time, but just like me, they could not figure him out. And so he was unable to treat himself. He ended up using heroin as a painkiller, and a lot of people are in that boat. They can't get diagnosed. Just as a stat, current clinical genome sequencing, that means from end to end, you get at the doctor's office, only has a 30% diagnostic rate. That's really bad. That means 7 out of 10 people are basically misdiagnosed or just, oh, I'm sorry, I can't figure it out. Or psychosomatic like me, which means insane. That's what they diagnosed me as, even at Hopkins and Columbia, insane. Anyway, so I had 4 genomes from 4 different providers, top institutes all throughout the world, top ranking, and they could not diagnose me with what's called short read sequencing. So, sorry to get a little technical here, but what they do is they chop up the base pairs into segments. So it's 3.2 billion base pairs for the whole genome, right? It's long. They can't do one to the other. So what they do is they chop it up into little pieces. And short read sequencing, which is what you get everywhere, right? Any provider, direct to consumer or at the doctor's office, it chops it up into little segments that are only 100 long. And then it stitches it back together after it sequences all these 100 little strands, right? The problem with that is that there are parts of the genome that are very repetitive. They go GC, 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 GC for tens of thousands of characters. And so what happens is that when it's reassembling, you get what's called sequence gaps, right? And so a lot of people aren't diagnosed because their diseases, like mine, were in a sequence gap area, dropped data. And so anyway, sorry to get a little technical on you. I just really wanted, it's a passion of mine, genomics. I really wanted to share that. And this is what led me into my diagnosis, my passion for research use only tools, blah, blah, blah. All of that came from this. So I read this paper in 2017, and this guy's my hero. He recently sent a book to me signed. I love this guy. What he did was he used the first person in 2017 to use like the 3rd gen iPhone of genome sequencing. It's called long read sequencing. So instead of chopping up the little base pairs into 100, it chops it up into 10,000, 100,000, even 1 million, even 5 million at this point. You know, you can control how big the pieces are, right? And so what that means is, think of it like a jigsaw puzzle, like with the short read, where there's like 10,000 pieces and you have to reassemble the sky and it's all the freaking same color. Try doing that. You know, long read sequencing is like, it's like a jigsaw puzzle, but it's made for kids. You know, and it's like, it's so much harder to like, you know, forget where each piece goes. Anyway, this guy right here was the first person to use it on a human, right? It was a research use only tool, not available clinically even to this day. And it's 2023, this is in 2017. He used this on a cardiac patient who could not get diagnosed with the clinical technology. And he used long read for the first time, and guess what? They found the defect. They found it. And so this guy's tumors, he has getting tumors on his heart. He finally knew how to molecular diagnosis. He understood what was happening to him. And so inspired by this guy, I basically bitched and bitched on Facebook until someone was amazing enough to help me out. I was just talking about why this technology should be more available to everyone, right? But someone reached out, they had a real heart. Her name is Matab Delara Cesari, shout out to her. And she connected me with a guy named Cosmo Mielke, who then connected me with my best friend, Pete Kane, or one of my best friends. And Pete Kane hosted a hackathon for me. So this is getting into the DeSci part. So if you could just play the video, just turn it down a tiny bit, if that's okay. thank you for looking at my data and trying to come up with avenues for me to get free from this. So thank you once again. Thank you so much. So, in case you guys may be wondering why my Twitter is undiagnosed1, that was the name of my hackathon that changed my life, and that was the best weekend of my life. In 3 days, what the clinical space couldn't do in 17 years, they found the gene that was causing my problem. And, you know, I was so touched by all of this, all these people from Stanford, Harvard, Yale, MIT, you know, NVIDIA, Japan, London. I can't even name them all, but I was touched. I was tearing up constantly there. I had to hide it, but it was so touching to have all those people that give a shit try and figure out why you're suffering when no one else believes you. That, you know, as you saw Kurt, right? No one believes him to this day. You know, friends of his think that he died because he couldn't handle fame or some nonsense like that, right? The guy was in abject misery, his so much pain, and that's what a lot of us deal with. And so what I really want to do with Biohacker DAO, and I'm sorry, I'm going to hand it off to my friend Mike soon, is essentially use blockchain to create a DAO so that we can basically expand this and give this to more people, this experience, right? People that are the 10% of the global population that don't have answers. We want to make precision medicine something that comes faster. And anyway, I'm going to give my friend Mike here knows all about DAOs. He's a blockchain master. He has a lot of cool things to talk about. So my fellow Biohacker DAO co-founder, Mike.
Thank you. Let's give another hand to John. What a touching story. It must be so difficult to suffer and only to be gaslit by your healthcare providers. And I know that's something that we all go through at some point in our lives. But those who are sufferers of rare diseases, that is a whole another realm of difficulty. And only recently have we had the tools to really address this problem. So unfortunately, Kurt Cobain ended his life far too soon. And we didn't have the tools to even diagnose his issue. It had no name, much less fix it. But now we live in a future where we have these solutions. So about 9 years ago, the Nobel Prize was issued for the discovery of CRISPR. And just this year, we finally are seeing a drug with CRISPR coming out. So now the question, CRISPR is being used to treat hereditary genetic issues such as Ehlers-Danlos. Could it be used here? Well, there are a number of problems with that. Now, one of the big problems is that the CRISPR treatment that's coming out right now is treating a particular issue, which is sickle cell anemia, which is terrible, but it is only a mutation affecting one gene, and it's a SNP. It is only a single nucleotide polymorphism, so there's only one change to one gene. That is an ideal case for CRISPR. So what is CRISPR? A bit about that. It is the cell's antivirus system, right? If you live in a world where everyone is getting hacked every time, how do you protect yourself? Well, I'm a security engineer by trade, actually. didn't perhaps introduce that. I'm actually one of the top security engineers on the planet. I'm top in 3rd% on Stack Overflow, top 5 for security and cryptography answers. I worked solving very difficult problems. What I did, I had a background in linguistics, math, bioinformatics, computer science, and I hacked banks. E-Trade, Square, PayPal, Intel, Adobe, they've all my clients. A lot of the work is all private, it's protecting them. Now, when you are doing this kind of line of work, when people tell you, you can't do that, it's not done that way. We don't do it that way here. Don't listen to those people. Tell them to either never say that again or get lost. That is not helpful, And by them saying it, we are now further away from a solution, because we need solutions that are completely outside of the box in order to take on something like a bank. And so I was tech lead. I would raise a team of us going through an internal network or pouring through some esoteric API in order to, trick it into giving us some money or whatever. And we were very good at it. Now, I rose, so yeah, CRISPR. So bringing it back to CRISPR. Sorry. Now, CRISPR is really interesting. So a lot of the same problems that you run into in computer security, particularly dealing with code execution, dealing with viruses, you see these same analogs in the biology space, and that is fascinating. Now, what you don't see in the biology space is a lot of the same tooling, right? Because they're so new to it, and also it's a lot of bioscientists. So a lot of the tooling is coming along. And so what I did is I've created a new type of tooling around this for creating, making it easier for individuals to create specialized therapies like treating Ehlers-Danlos. So although this in itself is not a cure, it helps us get much closer. And now how it does that is using machine learning. It uses, and this is really interesting. So now, and this is getting back to breaking the rules. So now, if I were to make a drug to heal my friend, I would have to go through FDA approval, right? Well, I mean, recently we have the right to try, but going through FDA approval for CRISPR therapies is arduous. And it also forces you to make a drug that is off topic. The reason why is because you have to show that your drug works with every sufferer. In the case of Ehlers-Danlos syndrome, there is no one gene. It can be 13 to up to 20 genes, and then any number of modifications within that gene. So making a one-size-fits-all cure for that is very unlikely. Except, I can make a very custom-tailored cure for one individual. And I can prove, using modern computer science, that there's a very low likelihood of problems arising. Now, this is interesting. And this certainly should be explored, because I think that in the future, if we look at a lot of our medicine and how we go through medicine approval, there's a lot of problems with that. Most recently, an Alzheimer's drug was approved that did not help with Alzheimer's. This is not an isolated case. So we should really reevaluate the FDA, and it may be limiting new forms of treatment that are coming out. So, politics aside, we are empowered more than ever with modern technology. It's important for us to come together and to share our insight. And the open source community has been doing that for decades. And really, that is what a DAO is about. So instead of being an open source community strictly on software, people are in the film space, people are in the art space, or decentralized science. Thank you all.
Thank you, Rook. Yeah, I told you guys, he's absolutely brilliant. He should definitely get his contact info if you have any science questions. So I just wanted to close and say that, Rook, who has also an autoimmune disease himself, which is a different kind of disease, and my friend Stanley, we're all mutual best friends, he has a chronic condition as well, a chronic pain condition that's uncharacterized. The three of us have come together to create what we're calling Biohacker DAO, and that's going to be on the Tezos blockchain. And so what we want to do is we want to basically just expedite, diagnostics and therapeutics by using a lot of the research use only tools. Those are tools that are not clinically available. You can't get your doctor to write them. Those are tools that are still in experimentation phase. And we want to deploy those right now on people that are suffering intractable illnesses. So anyway, that's Biohacker DAO. That's our mission. That's our story. And thank you very much for listening to us.
Guys, there you go. Hello? Hi. Guys, that was incredible. Please, another round of applause for John. That was really, really so touching and just such an unbelievable story. And you know what? It's stories like this which really underline the mission statement of why we started Nova 3. We wanted to be able to have these kinds of conversations and hear these kinds of stories every week, and as a matter of fact, every day. And this is also why we have decided to start Nova DAO, so that we can invest in causes like this. For those of you who don't know, 10% of all membership fees, if you opt in, are going to be applied toward the DAO, and we're gonna have votes. And Biohacker DAO is definitely something that we're gonna be shortlisting and considering as one of our investments. So, guys, thank you so much. Iga will be conducting the rest of the program for tonight, so I'm going to pass it over to her. But I so appreciate everybody, and most of all, John. Thanks a lot, guys.
Thank you so much. So guys, right now, if anybody has questions that you guys want to say out loud to our speakers, I would love to ask those questions, and after that, everybody will have an opportunity to introduce themselves and tell us what are you guys doing in the space, so we can all connect and build this community together. So, question? Who has a question? Jimmy?
I've got a bunch of questions. I've got a bunch of questions for you guys. Let's start with John first. John, excellent. I really, really appreciate you guys coming by. Thank you so much. My question to you is, where do you see this now that this is kind of like, you've taken all those years, now just kind of, you've gotten on pretty much a lot of the answers. What's the next step now? Like, what's the next step in that direction?
So is that question more for me, myself, or more on the scalability level? Sorry for deafening you guys tonight. I don't know. On the personal level, what I want to do is just get a slightly higher quality genome assembled. So I had a pretty high quality one, but just to get a little bit more technical, pardon me, the ultimate form of genomics, like the ultimate diagnostic, is something called telomere-telomere sequencing. So that means from end to end of the genome, perfectly, no sequence gaps. It's like a perfect copy of your genome. And that means that if all of you had that, you could run AI software on it and it wouldn't have any weird biases because of the sequence gaps. Like, it would be able to basically fully determine how you work, Yeah, so what I'm trying to do is get something like a telomere-to-telomere sequencing, and then Rook here is super awesome. He's been working, trying to come up with ways to edit my DNA, and then basically help cure my condition. He's really good with plasmid engineering and viral vectors. He's so damn smart, I'm telling you guys. And as for the scalability, what we plan to do is use Biohacker DAO to fund hackathons just like what I had. Sure. Maybe smaller scale, but we want to deploy research use only tools like what I had, and then open source it to bioinformatics. And for Mike.
Thank you. I do have one question for you though. So besides getting my other question about the pandemic 1918 incorrect. No, I'm just kidding, right? No, my question would be, what was the most difficult thing that you were hired or asked to hack, out of curiosity? Most challenging.
So most challenging client, most challenging project. A number of really interesting projects came through. Some of the more interesting projects would be where the client is getting in on the cloak and dagger, where you get a statement of work and it's empty. It says like, we own you for 2 weeks. And it's like, wait, what are we doing? It's supposed to be in the contract, what you're supposed to be doing, from the minute it's empty. And it's like, wait, what's going on there? And that was, they were being attacked by nation states. So, and yeah, I'm not gonna tell you who that was. It's all of them. They're all being attacked by nation states all the time. So those were really interesting. But to answer the most technically challenging, single most technically challenging is definitely Square. And I found a padding replay attack in one of their payment processors. And that was a very difficult crypto vulnerability. They were so excited. They had a PhD who had written the code, and he was so excited. He was like, you drink. I'm like, I'm on site, don't drink. He's like, no, you stop, you drink. and like poured me a shot at 18-year whiskey. So they were so excited when I approved that one. So yeah, Square, they really care. Wow, Jack Dorsey, yeah, anyway.
I have one more question right here. Here, John.
I'll keep it. Oh.
Okay, John, I want to ask, you're familiar with epigenetics, I'm sure, yeah?
Yes.
Now, wouldn't you be able to shut off those genes that are causing the problem?
So I'll let. So basically, no. If the underlying code that actually becomes proteins is Borky, and which is what Ehlers-Danlos is. So I have something called tennyson X deficiency. Basically, the code that makes up me, not the. So epigenetics is like basically switches on top of your DNA. Basically, the code that creates that protein is faulty, so my body's producing a messed up protein. And that protein is involved in muscle formation, in like stomach lining, so that's why Kurt had chronic intestinal pain, that's why I do too. It's because that tennyson X protein is expressed in the gut as a protector, as a barrier lining, and I don't have that barrier lining, so it's always red and always inflamed throughout my entire gut. So epigenetically, there are diseases where you can have, you can silence one bad, if you have like a dominant gene, that's, you can silence it.
Yeah.
And then, but yeah, this is not one of those cases.
And you had that like your whole life?
Yes, Ehlers-Danlos, a lot of us, it begins in, in infancy.
But
So-
that means at some point you did not have it.
No, I mean,
It expresses at some point?
well, it got worse when I was about 20. I started having daily vomiting, so I vomited 3 times a day, and I don't know how the hell I got through Berkeley, but I was vomiting in between classes, like I'd just go to class and I'd just throw up, and then later that night I'd go to a research hospital, and then they'd like shove cameras down my throat and like try to analyze me, and I just started studying science on my own, receptors, genetics, I mean later on genetics, but microbiome, all that stuff, I really got really deep into it, and that's kind of how I found that guy, just constantly reading, trying to figure out an answer.
Well, wish you luck. I hope you can defeat this and move on.
Thank you, man, really appreciate that.
All right, thank you so much. Sorry, I'm going downstairs. Do we have any more questions for our speakers? I cannot see yet. Do we? Ryan?
Just to answer that again, so similar to people with sickle cell anemia, that is the gene in hemoglobin is the one. So if you just silence the gene for hemoglobin, you no longer have red blood cells. So you're no longer going to be very happy. In this case, Ehlers-Danlos is a protein involved in stretchiness, so you're just kind of more stretchy in general. But yeah, it has a lot of effects throughout the entire body, and including, yeah.
So it's basically like bad code. That's what it is.
Yeah, exactly.
Bad code.
Alrighty. So, John and Mike, last thing, just tell us guys how we can connect with you, how we can be a part of what you're doing, what's the best way to connect with you.
So as for me, and I'm going to let Mike answer himself, for me, my Instagram is undiagnosed1, that's the number 1, and my Twitter is undiagnosed_1, which you can choose whichever one you like there. And Mike, he has a couple social medias.
Yeah, so the main project related here is the plasmid compiler, and if you search for that on GitHub, you'll come up. I'm the only one. So certainly we're looking for people in the biology space. Pull requests welcome. So anyone who is in biosciences, bioinformatics can definitely join that effort. Thank you all.
Oh, and your socials.
Thank you so much, and let's get to the networking part.